Okay, so I'm going to begin with the parallel line construction. I'm going to show you how to construct a parallel line to this line that's in front of you here, okay, through a point off of the line. So I have some point. Okay, in this lesson, we'll be doing the parallel line construction two ways. Then we'll be going through angle vocabulary and properties related to parallel lines, and we'll be doing a lot of algebra. So this would be the question on the regions, okay? You would have a given line, you'd have a point off of the line, and they would simply say, construct a line parallel to the given line through this point. Okay. Construct a line parallel to line. That's the symbol for parallel. Okay. I'll call this line M. To line M through point A. So this construction I'm going to do is called the rhombus construction. So the way this goes is you put some point on your line, call it whatever you want. I'll just call it V. Okay, so you put the center of your compass on B. Okay, this is called the rhombus construction. And then you have your pencil, okay, pass through point A, okay, down to your line. You get that intersection. You can call that whatever you want. So let's just say I call that point C. So the distance from B to A is the same as the distance from B to C. So then you take turns. You keep the same radius setting that you already had on your compass, but you take turns going from A and swinging your compass over in this area, because you're also going to go to C and use the same radius setting. So your goal here is to get these two arcs to intersect, the arc from A and the arc from C. Now once you get that intersection, okay, I will call that intersection D, let's say. Then you draw a straight line from A through D, and we'll call this line N. And so these two lines will be parallel. And so we did this construction through properties of a rhombus. You'll understand the construction a lot better when we do properties of a rhombus. But this is line N. So the way it works is in a rhombus. Okay, a rhombus is a parallelogram, so opposite sides are congruent. So by making these distances, the distance from B to C, the same as the distance from B to A, which is the same as the distance from A to D and from C to D, you have a rhombus in the background, and all four sides are congruent. So that's what's going on with this construction, is that you're making this line N parallel to line M, because you're making a rhombus working in the background and the opposite sides are parallel. Okay, that's the rhombus construction. I feel that's the easiest construction. There is another construction people like to do. Okay, and that is the parallel line construction through alternate interior angles. Parallel lines through alternate interior angles being congruent. So this construction is going to be based off of copying an angle. So before I can do this construction, I need to show you how to copy an angle. Okay, kids. So the first step to copying an angle is you go to the vertex of the angle that you want to copy, and you make an arc, any arc you want, okay, that intersects both sides of your angle. Now you keep that compass setting and you go to where you want to copy the angle. So I'm going to copy the angle on one of these endpoints, so I'll go to the left endpoint. Okay, so I'm putting my center there, and I'm just doing the same thing I did. I'm swinging an arc, the same sized arc that I had in the last problem. Okay, so then what you do is you go to the original angle, and you can go to either of the intersection points on either of the rays of the angle. It doesn't matter which one. So you're going to put the center of your compass, okay, on the one end. Then you're going to set your compass okay, so that it passes through the other intersection point. Okay, what you're doing is you are measuring how wide the angle is. Okay, and I'm just tightening up my compass here. Okay, so you swing an arc through that intersection. Then you go to the intersection of your first arc on the location you're copying it to. Put the center on that point, and then swing your arc with the same radius so that it intersects the first arc. Okay, so now you can call these whatever you want. So let's say I call this A and this B, right? So what I did is I took my compass, I made it pass through A and B. I'm calling this A prime. Then when I got the intersection, that was B prime. Okay, so now I'm going to connect this endpoint through B prime. Okay, and these two angles are congruent. So next up, I'm going to show you how to do the parallel line construction through alternate interior angles being congruent. Okay, so this is going to be the copying an angle, but the angle that I'm going to copy is this angle B up to this angle A. So I start by putting my compass on B. Okay, I swing an arc that intersects both sides of my angle. Okay. Then you go to A, you keep the same radius setting. Swing an arc upward. Okay, I'm actually doing this not through AIA or congruent. I will change that in a moment to corresponding angles. Anyway, so what I did is I centered my compass on B, swung the arc, centered my compass on A, swung the arc. So then I'm going to go to one of these intersections. So I'm going to choose to go to the intersection on this dark line, and I'm going to change my setting so that my compass passes through the other intersection point, just like I did prior. Okay, so swing your arc, then go over to the image of this center point, which is all the way above A, and swing the arc again. So now what you're going to do is you're going to draw a line from A through this point of intersection. and then these two lines are parallel. And it's not from AIA. Sorry, I just get so used to AIA. It's from corresponding angles are congruent. Then the lines are parallel. Line M is parallel to line N. Okay, so that's just another construction. You can choose either way. I prefer the rhombus method, but a lot of people do prefer the corresponding angle. It's congruent method. Okay, so the properties that you need to know, okay, about parallel lines are that, okay, when two lines are parallel and cut by a transversal, okay, so you have two parallel lines cut by some transversal. Okay, I'm labeling the angles 1, 2, 3, 4, 5, 6, 7, 8. So the deal is alternate interior angles are congruent. Okay, I'm going to list the pairs of these. Alternate exterior okay, corresponding angles are congruent. Okay, and then same side interior are supplementary. There's also, of course, in this picture, there are linear pairs, there are vertical angles. They already exist here because geometry comes in layers, okay? So same side interior are supplementary. Okay, so the alternate interior angles, how you're going to recognize this is if you make a Z, okay, engulfing the 4 and the 6, angle 4 and angle 6 would be congruent when these lines are parallel. Okay, we would show these lines are parallel by drawing these little arrows on them. So the other pair, if I make a backward Z, so if I make this really wide backward Z, you see I see angles 3 and 5. So those are congruent, which means they have the same measure when those lines are parallel. So if I said angle 3 measures 120 degrees, you would be able to say angle 5 measures 120 degrees because the lines are parallel, so the alternate interior angles are congruent. Now, alternate exterior angles are going to be exterior to the parallel lines, but on alternate sides. So those pairs are angle 2 and 8. Okay, at some point you were taught this. Doesn't mean that you guys remember it. That's why I'm reviewing it. Angle 1 and angle 7. So those are alternate exterior angles. Those are congruent as well when the lines are parallel. Now the corresponding angles, imagine you were to take angle 2 and you were to slide it down onto the other parallel line. It would land on angle 6. Okay, you could see that it forms a letter F. That will help you to recognize corresponding angles. So alternate interior angles, you can think of the Z's, forward and backward Z's. And then for corresponding angles, you can look for an F, any way, shape, or form. Okay, it could be backwards, flipped, rotated, anything. So the pairs would be angle 2 and angle 6, then angle 1 and angle 5, angle 3 and 7, and then the last pair is 4 and 8. Okay, so these are congruent. Now, same side interior, there's only 2 pairs. Okay, angle 3, the measure of angle 3 plus the measure of angle 6 is 180 degrees. Those are same side interior. You see that they're interior and on the same side of the transversal. And then the same thing with the measure of angle 4 plus the measure of angle 5. That is also 180 degrees. Okay, so the main thing that is done with this topic, besides proofs, which we'll eventually get to, is algebra. Okay, so here's the first example. Okay, given line L is parallel to line N. Okay, and we're going to find the measure of angles 1, 2, 3, 4, 5, 6, 7, and 8 using algebra. Okay, and you're going to be given a picture to go with this. So these 2 lines are parallel. This is L, this is N. Okay, so let me number these 1, 3, 4, 5, 2, 8, 7, 6. So first I'm going to give you expressions for 2 of the angles. So the measure of angle 1 is expressed as 5x plus 10 degrees. And the measure of angle 2 is expressed as 7x minus 30 degrees. So these lines are parallel. You need to recognize the vocab word for this pair. So this pair of angles are alternate and exterior angles. So when lines are parallel, alternate exterior angles are congruent. Get used to writing these statements out. It will help you when we get to proofs. So you set these expressions equal, solve for x, and then you're going to sub in. So subtract 5x from both sides. 10 is 2x minus 30. Add 30. 40 is 2x. So therefore x is 20. Okay, so the measure of angle 1 is going to be 5 times 20 plus 10, or 110 degrees. The measure of angle 2 is the same. Okay, we already know that they have to be the same, right? So now what I can do is I can say, okay, 1 and 2 are both 110 degrees. So you know that angle 2 and angle 5 are corresponding. So the measure of angle 5 is also 110 degrees. And angle 1 is corresponding to angle 7, so that is 110 degrees. Now the other 4 angles in the picture, so the measure of angle 3, 4, 6, and 8 are all 70 degrees. And you could just use linear pairs. Okay, so linear pairs are supplementary, so all of these have to be the supplements of their linear pairs. Okay, let's take a look at another problem. So in this picture, I have line K is parallel to line J. Okay, and the transversal is this other line P. I'll make the first transversal Q. It doesn't matter what you make it. Anyway, so let me number these. And again, it's going to turn into algebra. So the measure of angle 3 is expressed as 8x degrees. The measure of angle 6 is 5x minus 15 degrees. So you need to find those in the picture, 3 and 6. Those are same side interior. So same side interior are supplementary. And you should make yourselves write that down. Same side interior are supplementary. Okay, so they add to 180. So we get 13x minus 15 is 180. Add 15. And then divide by 13. Okay, you have a calculator for that. After you get x is 15, you go back and sub in. So the measure of angle 3 is the same as the measure of angle 1, by the way, right? And then corresponding angles is the same as the measure of angle 7. And that's the same as the measure of angle 5. You can use alternate reasons. Angle 5 is vertical to angle 7, for instance. Anyway, so all of these are going to be 8 times 15. Okay, so that's 120 degrees. And then all the other angles, so the measure of angle 2, angle 4, angle 6, angle 8 are all going to be supplements of those because they're linear pairs, and linear pairs are supplementary. Okay, so in the first one we had done alternate exterior angles were congruent, right? Because we had angle 1 and 2, which were alternate exterior. In the second one, we did same side interior or supplementary. Okay, let's take a look at a problem that's going to lend itself to factoring, which you guys told me you hadn't done in a while. Okay, so this is a much more complicated problem. Hence, high school, right? So this pair of lines are parallel. So if you look at these angles here, if I make this transversal, right, and I look at this, pair of parallel lines. Okay, if I look at those angles, 2x squared and x squared plus 25, those are alternate exterior angles. So you can set them equal. Then you use algebra to solve. So I get x squared is 25. Now x would normally equal plus or minus the square root of 25, which is plus or minus 5, but let's see if it makes sense to be negative 5. It doesn't make a difference. Okay, anyway, when we sub in, we'll get the same angle measurements. So 5 squared plus 25 is 50, so these angles measure 50 degrees. The other pair of parallel lines in this picture are AC and FE. Okay, and then look at this transversal. Okay, so this angle here, right? And this angle up here that they're talking about, if you look very carefully, those are alternate interior angles. So when you have parallel lines, alternate interior angles are congruent. This other one relied on the lines being parallel. You had parallel lines and alternate exterior angles were congruent. So that means we have 3y plus x minus 36 equals y plus x. Now these x's can cancel out. So we have 3y minus 36 is y. Bring the 3y over. So you have negative 2y is negative 36. And then y is 18. Okay, and then you can always sub in to get the angle measurements. Okay, but that is a typical algebra problem. Let's take another look at an algebra problem. That one really didn't involve factoring. Okay, the next one is going to involve factoring. Find x so that line L is parallel to line M. So this is line L, this is line M, and they're parallel. Okay, so this is a transversal intersecting them. So this angle is 4x plus 11. this angle is expressed as 2x squared minus 10. So what kind of angles are those? Yes, alternate interior angles. Are they congruent? Don't always assume they're congruent. They're only congruent because we have parallel lines. So you need that condition. So the alternate interior angles are congruent. So we have x squared minus 10 is 4x plus 11. I'm going to bring everything to the left. So I get x squared minus 10 minus 4x minus 11 is 0. So I'm just going to put this in standard form. So now we need to factor. So it's been a long time since you've done this. We need two numbers that multiply to negative 21 and add to negative 4. So what are those two magical numbers? Negative 4, positive 3. You set these equal to 0, then you use something called the zero product property, which tells you that if the product is equal to 0, either one or both of these factors have to equal 0. So we get 7, and then we get negative 3. The negative 3 gets rejected because it doesn't make sense to have a negative angle. 4 times negative 3 plus 11 is negative, so reject, and so x would be 7. Okay, so be prepared to do that. One more thing I need to show you that's in the Common Core curriculum is something called an auxiliary line. It's only been on one regent, so don't know if it will be on again, but I'm going to show you anyway. Find the measure of angle 1. And here's the picture. So I have these two parallel lines, and then I have this here. They tell me this is 48, and they tell me this is 54. So the strategy to doing this problem is you would make an auxiliary line through this vertex parallel to the other two lines. Okay, and I'm asking you to find the measure of this angle here. Okay, so you would carry the 48 degrees up because when you have parallel lines, alternate interior angles are congruent. Then you would carry that 54 down. So the measure of angle 1 is 54 plus 48 degrees. Okay, so just be prepared to be able to do a problem like that as well. All right, that concludes this video. Thank you.